Hello students, welcome back to our channel Diksha Karnataka. So your COMEDK 2024 provisional answer key is released. So in this video, I'll be discussing the exact solutions of all the questions, all the 60 questions of chemistry that was asked in the COMEDK 2024 examination. So in this video, I'll be discussing the paper of shift 1, that is your morning session, which was conducted between 8:30 am to your 11:30 am, right? So let us start with the first question. So let us see the first question here. So the first question was from your electrochemistry chapter. Okay. So what would be the EMF of the cell in which the following reaction occurs? So this is a direct question from your Nernst equation. So you know the formula for Nernst equation is E of the cell is equal to E naught of the cell, okay, minus 0.059 by N log of product concentration by reactant concentration. So if you see the equation, CD2 plus is the product and H2 is there. So we can put here CD2 plus concentration and the pressure of H2, okay, divided by the concentration of the reactant, that is H plus concentration and its square. Now what you have to do is just you have to substitute all the values. So if you see here, E naught of the cell will be what? E naught of cathode minus E naught of anode. So if you see here, CD2 plus is your anode and H plus to H2 your cathode, and the reduction potential of hydrogen is considered to be 0. So 0 minus of 0.4, so we will get plus 0.4 minus 0.059. N value will be 2 electrons are used, log of, then what is the concentration of cadmium 2 plus 10 to the power of minus 2, okay, and then pressure of H2 is your here given 0.8 divided by H plus square, that is 2 into 10 to the power of minus 2, its square, right? So now if you substitute these all values and do the calculation properly, the correct answer will be getting around is 0.3616, okay? So the correct answer for this question was option number C, that is 0.3616. Now let us see the question number 2. Identify B and C among the following in the reactions given below. So first we have C3H4Br zinc dust, okay, and then we have given heat, then B is formed, then Hg2 plus H plus, and then C. So now if you see, C gives iodoform test, okay, that means what? It must be a methyl ketone group must be present. Now if you're adding Hg2 plus to something and you're getting this aldehyde and ketone, then B must be some alkyne group, right? Now if you see, B can be formed from your haloalkanes, right? So C3H4Br4 will have C3H4Br4. So we can have this one, right? Br4, and then we have H4. Now here what happened, when we provide zinc, there will be elimination of Br2, there will be elimination of Br2, and we will get here this one, okay? So now this is your B, okay? Now when you provide Hg2 plus and H plus, what happens? We get compound like this, CH, then we have double bond, here we will get H, here we will get OH, and then we have CH3, and then there will be tautomerization and we will get CH3, CO, and then CH3, right? So since here there is a methyl group present, methyl ketone group is present, it will show you positive iodoform test. So the correct answer for this question will be, that is B is your propyne and C is propanone, right? Correct answer is option number C, D. Now see the next question. Identify the two chemical tests which is not answered by glucose having an open chain structure. So the question is from your biomolecules chapter. So reaction with Skiff's reagent and with sodium bisulfite, these two reactions are not shown by the open chain structure, it was shown by your closed form structure, right? So the correct answer will be your A statement, which is there in option number D. So correct answer is option number D, okay? Now let us see the next one. A D block metal Z is equal to 26 forms a compound of XCN2CO4 plus. Calculate the spin magnetic moment value. Here many students might have done mistakes. So this question is from your coordination compound, right? Coordination compound. So if Z is equal to 26 means X is iron, right? Now what will be the oxidation state of iron here? So let it be X minus 2 is equal to plus 1. So we will get X is equal to plus 3. So Fe in plus 3 state, what will be the configuration? 3d5. Now you might think 3d5 means 5 unpaired electron and the the magnetic moment will come around 5.92. But you have to see the question is asked in this compound. So Fe is with the ligands. So when it is ligands, it is with the ligands, there will be splitting of d orbitals, and both are very strong ligands. So there will be like the splitting will be more, and pairing of electrons will take place. So 1, 2, 3, 4 and 5. So there is one unpaired electron. Now if you calculate the magnetic moment, then it will be root over of 1 into 1 plus 2. Okay, so we'll get around 1.7. So correct answer for this question will be option number B, that is 1.7. Now let us see the next question. Which one of the following compounds show geometrical isomerism? So this is from your basic, that is your hydrocarbons chapter, right? So how to understand geometrical isomerism? That the complex, suppose you have any alkene group, okay, X and Y, the X should not be equal to Y. Okay, in that case only we can get geometrical isomerism. Now if you see the structures here, okay, so let us draw all the options. One second. Okay, so now if we do option number A and B structures, so first is 2-methyl hex 2-ene. So first I'll do this one. So 1, 2, 3, 4, 5 and 6. So on the second carbon we have double bond, and then on this one we have 2-methyl. So now if you see this side, on this carbon, this group and this group are same, methyl group, right? So in that case they will not show geometrical isomerism. So this option is incorrect. Now 4-methyl hex 2-ene. So if I just modify this one, we will get 4-methyl hex 2-ene. So now if you see this one, 1, 2, 3, 4. One second, yeah, we'll get this one. Okay, so now if you see in this carbon, okay, 4-methyl hex 2-ene. So here there is H and here there is H. These two groups are different. These two groups are different. It can show you cis and trans isomerism, or we can say E and Z. So the correct answer for this question will be option number D. Now let us see the next question. A sweet smelling organic compound C9H10O2 undergoes acid hydrolysis to form an acid B and form an acid B. Compound B further reacts with ammonia followed by heating to yield C. Compound C, when heated with Br2 in presence of caustic soda, give you compound D, that is C6H7N, which gives a white precipitate with aqueous Br2. Identify A and D. So first, whenever you see this type of questions, it is very essential to first draw the diagram or the scheme for the question. So first is there, you have A, okay. Now what is about A? The molecular formula is C9H10O2. Now if you see a sweet smelling compound, it is more likely to be an ester. Now when you do this one, hydrolysis, right? If you have hydrolysis, then what we will get? Compound B is formed, okay. Now compound B will react with ammonia, okay? Forms an acid. So this is an acid. So you know, when you hydrolyze an ester, we get an acid and an alcohol. So we are talking about B. Now when this B is an acid and this is your ester group, okay. Now this one B further reacts with ammonia, okay, and to give you C, okay. Now what is there? The compound C reacts with Br2 and caustic potash, right? So this one we will get D. Now here if you see, it is C6H7N. And you know, this is your Hofmann bromamide degradation. So there must be, so 6 carbon means here must be 7 carbons, okay. Next it is giving you with Br2. With Br2 it gives white precipitate, okay. So this one is definitely aniline, okay. Now from aniline, if you are getting this one, so B must be benzamide, right? Now this one must be then benzoic acid. This type of questions you must go from back. Now if this one is formed here, so we will have like this one, A should be of this type, because we have C9, right? So 6 carbon here, 7th, 8th and 9th, and we have H10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These many are there, right? So now if you see, this is the structure of the A compound and this is the structure of D compound, okay. So D is your aniline. So D aniline is 2 options. We can eliminate these 2 options, and this one is your ethyl benzoate, right? So the correct answer for this question will be option number C. Okay, next question. Arrange the following in the increasing order of their hydration enthalpies. So if you know, hydration enthalpy is proportional to delta H of hydration is proportional to size. Okay, smaller size, more hydration enthalpy. Now if you see the elements, they are chromium, manganese, cobalt and nickel, right? Now we know along the period size decreases, okay, but if you see chromium and manganese, the size of manganese is bigger than that of chromium, right? So what is the order of size? Size order is manganese, then chromium, then cobalt and then nickel, right? So hydration energy will also be the same value. So the correct answer for this question is Mn2 plus, Cr2 plus, cobalt 2 plus, nickel 2 plus, that is option number D. Okay. Now next question, what is the final product when toluene undergoes the following series of reactions? So first we have toluene, that is your CH3 with a benzene ring. Then what we have done? Nitration. So toluene is an ortho-para directing group. So nitration or NO2 group will be added at the para position. We know para is the major product. So we will have CH3 and then we will have NO2. Now if you have treated with FeNHCl, so it is a reducing agent. So NO2 will get converted to NH2. Okay. Next we have CH3CO whole 2O. So this is your acylation of this group. So we will get this compound. Here we have CH3. Here we have NHCO CH3. Okay. So now if you see, this compound is your 4-methyl. Okay. So we have 3-methyl chloro is not there. 3-methyl aniline is not there. So 4-methyl acetinolide. So the correct answer for this question will be option number C. Now let us see the next question. The time required for 80% of a first order reaction is Y times the half-life period of the same reaction. What is the value of Y? So the question is telling the time required for 80% of a reaction is Y times the T half of the same reaction. If that same reaction is there, the rate constant value will be same. So now for this one, what we can write? This one will be 2.303 by K log of 100. Okay. Now 80% is already reacted, right? So how much will be left? 20 will be equal to Y times of T half is 0.693 by K. Okay. So now if you see here, what will happen? This K and this K we can get cancelled, and this one is log 5. So 2.303 by 0.693 log 5 is equal to Y. 2.303 by 0.693 into log 5 you have to calculate. So once you calculate this one, this value will be getting around is 2.32, right? So the correct answer for this question will be 2.32, that is option number B. Okay, so you can just do the calculation and check this one. Okay, next question. The standard enthalpy of formation of CH4, standard enthalpy of sublimation of carbon and the bond dissociation enthalpy of hydrogen are minus 74.8 plus 719.6 and 436 kilojoule per mole respectively. What is the bond enthalpy of CH bond in methane? Okay, so this question is also like very good question. So first, whatever enthalpies are given, that you must write in the reaction form, in the form of reactions. So first one is given is sublimation of carbon. So sublimation of carbon means carbon solid to carbon gas. What is the value given here? The first one is enthalpy of formation of CH4. So CH4 enthalpy formation, if we want, so first we'll write in the order. So enthalpy of formation of CH4, C plus 2H2 will give you CH4, and the value here is minus 74.8. Next is your enthalpy of sublimation of carbon. Enthalpy of sublimation of carbon. So this energy is your 719.6. Okay, and then we have bond dissociation enthalpy of hydrogen. So hydrogen is there, okay, and it will break to 2 hydrogen. So the bond dissociation enthalpy of hydrogen gases delta H is 436. Okay. Now you have to calculate the bond enthalpy of CH bond in methane. So if I want to calculate the enthalpy of this reaction, okay, so the delta H of the reaction is equal to delta H sublimation of carbon plus 2 times of bond dissociation enthalpy of H2, right, minus bond enthalpy of CH4. Okay, 4 times the bond enthalpy of CH bond. Okay, we have to calculate that. So now delta H of this reaction is given to you minus 74.8 is equal to delta H of sublimation is given to you 719.6 plus 2 times of bond enthalpy of hydrogen will be 2 times of 436, right, then minus 4 times of CH bond. Why we are taking? Because in CH4 there is 4 CH bond. So what I am writing is total enthalpy of products minus reactants. So now if you see and solve this, we will be getting around 166 something here is equal to 4 times of CH bond. Okay, now if you divide this one, we will get around 400 and value will be 416.6. Okay, 1 second. So the value here we will be getting will be 416 point something. Okay, that is your CH bond. So the correct answer for this question is option number B. Now seeing the next question. From the following compounds, identify the one which is most acidic. So while revising also we have discussed acidic and basic nature questions are very common. So most acidic means it should have some electron withdrawing group for the for stabilizing the conjugate base. So now if you see NO2 group is an electron withdrawing group. It can stabilize the conjugate base formed here. So that is why that will be the most acidic. So C will be most acidic. That is your option number D. Next question. An inorganic salt comprises of atoms of element A, B and C. If the oxidation number of A, B and C are +3, +6 and -2 respectively, then what is the possible formula of the compound? So see here, this one you can solve it just by checking the hit and trial method. The total positive charge and the total negative charge should be equal. Now if I check for first one, we have how many A? We have 3A, okay, and we have 4B, right, and we have 12C, right. So these are cations, these are anions. So if you check the total charge of this one, each A is +3, 3 into +3 is 9, then 6, each B is +6 and there are 4B, so 4 6 are 24. And here if you see 12 into -2 is -24. So you can see +24 -24 will cancel, but this 9 remains not cancelled. Now this is your for the first option. Now if you check for the second option, similarly we have 2A, okay, and we have 3B and we have 12C. So now if you see +3 is there, 2 into +3 that will be +6. Then we have 3 into 6 that is 18. Now if you see 12 into 2 that is -24. So 18 and +6 is +24 and this one is -24. So now if you cancel this one is balancing the positive charge and negative charge. So this can be the correct formula. So the correct answer for this question will be option number B. Okay. Okay. So let us see the next question. The rate constant for the reaction A gives B plus C at 500 Kelvin is given as 0.004 second inverse. At what temperature will the rate constant will become 0.014 second inverse? EA for the reaction is 18.231 kilojoule. Okay. So this question is very simple from your Arrhenius equation. So you have log of K2 by K1 is equal to EA by 2.303 R T2 minus T1 by T1 into T2. Okay. So now if you see here, the EA activation energy is given to us 18.231. I make it converted into joules. Then 2.303. Then you have 8.314. And then T2 minus T1, we have to calculate the second temperature. T1 is 500 and T2 into 500, right, is equal to log of K2. The second value rate constant is 0.014 and this one is 0.004, right. So just you have to solve this value and the temperature you will be getting around is 700 Kelvin. Okay. So the correct answer for this question is option number C. Okay. Now let us see the next question. An organic compound A, C5H12O, on reaction with concentrated sulfuric acid at 443 Kelvin gives B as one of the products. Compound B undergoes further reaction with O3 and ZnH2O to give propanol and ethanol as the as products. Then the compound A is. Okay, so again you have to first write down. So the compound C5H12O. Okay, this is A. Okay, and on reaction with concentrated sulfuric acid at 443, it gives you B. Now you must know that if it is undergoing ozonolysis, then B must be alkene, and this one must be alcohol, from which dehydration, concentrated H2SO4 causes dehydration. So this must be your concentrated, this must be one alcohol from which there is dehydration, due to which we got B, which is an alkene. Now from here what we have done, ozonolysis, O3ZnH2O. Okay, now this one is what? Here if you see, the products formed are propanol. So you can easily decide which alkene has been formed. Propanol and ethanol, I'll write like this, right? So here what happens, if you see, we will get, this part will be removed, right? And that will be replaced with a double bond. So what I'll get, C double bond C, right? 1, 2, 3, 4. So I can write this one as 2-methyl, okay, 2-methyl 1, 2, 3, 4, but2ene. Okay, this is the alkene, and this must have formed from the what we can say, the alcohol. So here we can just replace here. So I'll get like this, C OH and H, right? From here, if dehydration takes place, I'll get 2-methyl but2ene. So what is this? If you see, this is 1, 2, and then 3, and then 4. So 3-methyl butane 2OL. Okay, so the correct answer for this question will be option number C. Okay, let us see the next question. So now let us see question number 15. For the reaction Cl2 gives 2NO gives 2NOCl, the following data was obtained. You have to calculate the order of the reaction with respect to Cl2, NO, and the rate constant, right? So now if we see here, let us first write the rate of the reaction, rate law. So let the rate be equal to K into Cl2 to the power of X and NO to the power of Y. Okay. Now what we can do is, we can just check. Let's see, if you want to calculate the X value, right, Cl2 concentration, then NO concentration must be kept constant. So where the NO concentration is constant? Here. Now from here to here, what we have done, the concentration has doubled, then the rate will also double, right? So if the rate will double when you are doubling the concentration, then X value or the order with respect to Cl2 is 1. So I can say X is equal to 1. Now if you see NO, so when you are calculating for NO, Cl2 should be constant. So you can see in these two reactions, Cl2 is constant, and we are from here to here, what we have done, again we have doubled the concentration, and if you double the concentration here, the rate has become 4 times. So when we double the concentration and rate becomes 4 times, it is a second order reaction. So I can say that Y is equal to 2. Okay, now we can just substitute these values and calculate. So initial rate of the reaction is 0.6, okay, K value, then Cl2 concentration is 0.15, and then we have NO concentration is also 0.15 to the power of 2. Okay, so now I have to just solve it for K, and if you solve it, so we can first check if anyone is X, Cl2 is equal to 1, we have in these two options, okay, and Y is equal to 2, we have only in this option. So you need not calculate the K value also. Directly you can say that option, correct answer is option number C. But again, if you want to calculate, it will be 0.6 by 0.15 whole cube. Okay, so this one if you solve, we'll be getting around 177. Okay, so that is a very easy question. Next question, let us see. KH of O2 at 293 Kelvin is 34.86 kilobar. What should be the partial pressure of O2 gas so that it has a solubility of 0.08 gram per liter in the water at 293 Kelvin? Density of solution is 1 gram per ml. Okay. Now let us see here. What does this say? Solubility. Solubility is 0.08. Solubility is 0.08 gram per liter. Okay. Now if you see 0.08 gram per liter, and we need to calculate the solubility in terms of mole fraction. Okay, so what I can say, oxygen, right? So the number of moles of oxygen will be 0.08 by 32, right? So I can write by 8 by 32 into 10 to the power of minus 2. So that is 1 by 4 means 0.25 into 10 to the power of minus 2. Clear? Now what is the mass of in this? This is 1 liter. Okay, this is 1 liter, the water is 1 liter and density is given 1 liter means 1000 ml. So 1 gram, 1 ml is 1 gram, so 1000 ml will be 1000 gram. So this one, what I can say, mass of water is 1000 gram. Okay, the number of moles of water will be 1000 by 18, given mass my molar mass, that is 55.5. Now we can have the formula of Henry's law. So this question you will get pressure of the gas is equal to kH into mole fraction of O2, right? Now what is the kH value given? That is 34.86 into 10 to the power of 3. Okay, and then mole fraction of O2 will be this one. Let us write down here, mole fraction of O2 will be number of moles of O2, that is 0.25 into 10 to the power of minus 2 whole divided by, you can take this one as the Mohs value because this is a very small value. So we can write 0.25 into 10 to the power of minus 2 divided by 55.5. Okay, so now if you solve this, the value you will be getting around is 1.569. The correct answer for this question will be option number D. Okay, now see the next question. The permanganate ion in acid medium acts as an oxidant and gets converted into its lower oxidation state. What would be the spin-only magnetic moment of such reduced manganese ion? So if you know, manganese from +7 in acidic medium goes to Mn+2. And Mn+2 means what is the electronic configuration of Mn? That is 3d5 and 4s2, right? So Mn+2 will be 3d2, 3d5. So 5 unpaired electrons, so the magnetic moment will be 5 into 5 plus 2. So that will be around 5.9. Okay. So the correct answer for this question will be option number D. Okay. Next one. A3B4 is a sparingly soluble salt with a solubility of S gram per liter. If the molar mass of A3B4 is m gram per mole, what is the expression for its KSP? Okay. So now if you see here, we have the salt of A3 and B4. Okay. So now KSP will be equal to, okay, so 3 to the power of 3, x to the power of x, y to the power of y. So we know the general formula of KSP, that is x to the power of x, y to the power of y, s to the power of x plus y, right? So here x is 3, y is 4. So 3 to the power of 3, 4 to the power of 4, s to the power of 3 plus 4. Okay. So now if we solve this, we'll be getting around is 6912. Now here, if you see, solubility is in terms of gram per liter. It should be in terms of moles per liter, right? So how we can convert grams to moles? By dividing it with the molecular mass. So the molecular mass is m gram. So S by m. Okay. So S by m, 3 plus 4 is 7. So the correct answer for this question will be option number A. Okay. Next one. Given below are 4 graphs for A, B, C and D. So this question is again from your kinetics chapter. Right? Okay. So which of the following 2 graphs represent the zero order reaction? So ln term is there, means it is your first order. You can skip that. Reactant versus time, it is not a like parabola type curve for zeroth order. If you see this one, rate versus time, we have like concentration versus time. So we have the equation like this, right? R0 minus R is equal to KT. So if I want to draw a graph, so I'll write R is equal to R0 minus KT, right? So this is your negative slope and this is your y-intercept. So we will get this one as the correct graph. Now if you see the rate of the reaction versus R, so we have this one, rate is equal to K into R to the power of 0, that is only K is there, right? So now I can write the rate is independent on the, is not dependent on the concentration, so it will be a straight line. So both C and D represent, so the correct answer for this question will be option number D. Now see the next question. A given mass of hydrocarbon on complete combustion produce 176 gram of CO2 and 90 gram of water. then what is the molecular formula of the compound? So the question is from your some basic concepts of chemistry, empirical formula chapter. Okay, so if you see 170 gram of carbon dioxide is there, means how many moles of carbon dioxide? So 176 by 44, that is 4 moles of CO2. Okay, and you have number of moles of water, so that is your 90 by 18, that is 5 moles of water. Okay, now if you see in the organic compound we have carbon and hydrogen, so whatever carbon is present in the organic compound, that carbon must be from the carbon dioxide it is producing. So I can say whatever carbon is in the organic compound, the same amount of carbon is present in this carbon dioxide. So for in 1 mole of carbon dioxide we have 12 grams of carbon, right? So in 4 moles of CO2 we will have 48 gram of carbon. Okay, now similarly if you take for water, in 1 mole of H2O, okay, we have 2 gram of hydrogen, and then if you have 5 moles of H2O, we will have 10 gram of hydrogen, right? Now if you see the what we can say the number of, so now we can do the empirical formula carbon and hydrogen table you can draw. Carbon is 48 gram, hydrogen is 10 gram. Number of moles of carbon will be 4, this one will be 10. Now if you divide both by 4, we will get 1 and 2.5. To make it a whole number, we will multiply with 2, we will get 5. So what is the empirical formula? C2H5. Okay. Now the molecular formula is asked. So you know the empirical formula into N is molecular formula. So which number we can multiply? For example, if you multiply 2, then C4H10 we will get, that is there in the option. No other numbers we can get by multiplying any number. That is why the correct answer is option number C. Okay, next, an unsaturated hydrocarbon A reacts with HBr in presence of benzoyl peroxide to B. So we'll write first here, A reacts with H2O2 in presence of peroxide to give B. Now, compound A when reacted with cold dilute KMnO4. Compound A when reacted with cold dilute KMnO4, compound, it gave you compound C. Okay, and the compound C is 2-methyl butane, 2-methyl, okay, 2-methyl butane 2,3-diol. Okay, now but when A is reacted with hot KMnO4, okay, A reacts with hot KMnO4, it yielded CH3COOH, CH3COH and a compound D. Okay, now identify compound A, B and D. Okay, so let us solve this now. Okay, now if you see from here, you know if any double bond is there and when you treat it with dilute KMnO4, we get the double bond is replaced with diols group. So now if I have 2-methyl butane 2,3-diol, so where this 2,3-diol has come, there must be a double bond. So if I see here for A, if I am telling, okay, A, so 2,3-methyl butane, so first we'll do butane, okay, and at 2 position we have this one 2-methyl butane 2,3-diol. So here and here this one and this one came OH, right? So that means this OH was not present and in place of that double bond was present, right? So what we can do is replace this one with the double bond. Okay, so we will get 2-methyl butane 2,3-diol. Okay, now after this we got A. Now if you have HBr peroxide, then what will happen? It will follow anti-Markovnikov's rule. So anti-Markovnikov's rule if we follow and we add HBr, then what will happen? We'll get here C, 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 C and C. Br will be added here and H will be added here, right? So H will come here, Br will go here. So the rule is Br will go to the carbon having less number of hydrogen. So here there is Br will go to the carbon having more number of hydrogen, anti-Markovnikov rule. So here Br will be added. So we got B. Now next one is A, B and then okay, D is there. So now when you give hot KMnO4, what happens? The compound gets broken, okay, or if we can say the molecule breaks. So here there will be cleavage of the double bond and here we will get a ketone group and then it will be oxidized. So one we have already got is ethanoic acid, the another one will be your propanol, right? So because it is an ketone group, it cannot be further oxidized to acidic group. So first, if you see now, what is my A? A is your 2-methyl but 2-ene. Okay. Then B is 2-bromo 3-methyl butane, and D is propanol. So the correct answer for this question is option number A. Okay. Now let us see the next question. So this is about your D block elements matching D and F block chapter. Lanthanide hydroxide, you know, this example we have studied under basicity. It is more basic, right? So A will be with S. So A is with S. So we can eliminate C and D. Now if you see Mn2O7, Mn2O7 oxidation state is +7. Highest oxidation state means it is more acidic. So we can say B will be P. Okay. So B will be P. We can eliminate this one also. Correct answer is option number A. But let us see the other options. So lutetium hydroxide will be the least acidic, because least basic, because as you know, along the period the lanthanide contraction increases, the force of attraction increases, right? So that is why C will give you least basic, that is Q. And then Fe3H, that is your D. So this is an interstitial compound, that is R. SpQr. Okay. So let us see the next question. Choose the group of ions or molecules in which none of the species can undergo disproportionation reaction. So if an element is in the highest oxidation state or in the lowest oxidation state, then it cannot undergo disproportionation reaction. Now if you see the first one, right, if you see F2 is in 0, it can undergo only reduction. This one is in +7, it can undergo only reduction. Cl2 is 0, it can also undergo only reduction. But if you see chlorine here, this is in your +3 state, right? X -4 is equal to -1. So we have X is equal to +3. So this can undergo both oxidation and reduction. It can go to higher oxidation state and can also undergo to lower oxidation state. So this compound can undergo disproportionation reaction. So this one cannot be the answer. Now similarly, if you see Br will be in +4 +3 oxidation state, this one also can go to higher and lower oxidation state. So this one cannot be the answer. Now if you see here, it is +6, it will undergo only reduction. F2, it can also only go a reduction. Here +7, only reduction. Here again we have +7, only reduction, right? So that is why the correct answer for this question will be option number C. Now let us see the next question. What is the amount of ice that separates out on cooling a solution containing 60 gram of ethylene glycol in 250 gram of water to -9.3 degrees Celsius? Kf of water is given, molecular mass of ethylene glycol is given. So the question is again from your solutions chapter, delta TF freezing point formula. So delta TF is equal to Kf into M, we know, right? Now what is the value of delta TF? So delta TF is your 9.30 minus 9.3. Then Kf value is 1.86. Molality is how much? The mass of the solute is 60 gram and the molar mass of the is 62, okay, into 1000, okay, divided by this value you have to calculate, okay. So actually how much solvent was present, that much will calculate, and then you have to subtract from 250 to get the solvent that has formed ice, okay. So now if I calculate this one, you will be getting here, so we have this one as 0.03, right? Okay, now if we solve it, 9.3 divided by, okay, we'll calculate W1 here. So I'll take this one this side. 1 second. Okay, so W1 will be equal to 0.03 into 60 into 1000, okay, divided by 9.3. So whatever answer you get here, so now what we calculate is mass of ice separated out. Mass of ice separated, this one is equal to 250 minus this value, whatever you get after solving here. So now if you get this one and calculate, you will be getting around 56.45. So this one will be coming around 196 something, right? 194 something will get. So will be the final value will be getting around is 56.45 something. So the correct answer will be option number B. So this part you have to know how to subtract. You cannot put there 250 grams. Okay. Next, the compound X3Y is 60% ionized in aqueous medium. What is the Van 't Hoff factor? The value. Okay. So dissociation, we know Van 't Hoff factor I alpha is equal to I minus 1 by N minus 1. Now what is alpha value? Alpha value is 0.6. I value will be the number of, we have to calculate the I value, and N value will be the number of ions produced, that is 4 minus 1. So if I get here 0.6 is equal to I minus 1 by 3. So we'll get 1.8 is equal to I minus 1. So we'll get 2.8 is equal to I. So the correct answer for this question will be option number D. Okay. Now let us see the next question. A coordination compound is represented by the formula COBr3ENX. This compound required 1 mole of AgNO3 to form a pale yellow precipitate of AgBr. What is the value of X? So if you see here, there is only 1 mole of AgNO3 is required. That means only 1 bromine should be outside the complex. So if you see CO, we have right ENX Br2 and we have 1 Br outside. Now if you see this one here, coordination number has to be 6. So already 2 is present. Now here we can have one more, like each EN will have 2 donating sites or 2 ligands, so the density is 2. So if we have taken CO, EN2 and then Br2 and then Br is outside, then the total coordination number will be 4. Then 6. Then what is the value of En or X? That is 2. Correct answer is option number A. Okay. Now let us see the next question. Propane in presence of oxygen undergoes complete combustion to produce CO2 and H2O. The required O2 for this combustion reaction was produced by the electrolysis of water. For what duration of time had water been electrolyzed by passing 200 ampere of current so that the oxygen gas produced could completely burn 44 gram of propane? Okay, so this question is from electrochemistry, right? Again, easy question. Like little you have to think about the equivalent mass and all. So if we see propane is C3H8 plus O2 will give you CO2 plus H2O. Right? Now if I balance this one, it will be 3 CO2 and 4 H2O. Then we have 10, so I have 5 O2. Now propane is 44 gram. We have also taken 44 gram. That means this is 1 mole. Right? 1 mole and this is 5 mole. 44 gram is 1 mole of propane. Right? So I can say that for 1 mole of propane, 5 moles of oxygen is required. Now the question is asked, to produce this 5 moles of oxygen, how much current we have to rate, like how much time we have to pass the current, right? Now if you know the reaction for oxygen, it is O2 minus will give you 2O2 minus will give you O2 plus 4 electron, right? 4 electron means 4 moles of electron, that is 4 Faraday. So I can say with 4 Faraday of electrons, I can have 1 mole of O2, right? Then if I want to have 5 moles of O2, then we need 20 Faraday of current, right? So now what we can do is we can just calculate Q is equal to I into T and we have to calculate the time. So if you see 20 Faraday means how much coulombs? 20 into 96500 coulomb. Current given is your 200 ampere and time is time is T. So now if I want to calculate this one, we'll get 20. Here I can take 10. So I'll get 9650 seconds. Okay. So then what will be the value of hours? You have to convert it into hours. So divided by 3600, we'll be getting around 2.68 hours. That is option number A. Okay. Now let us see the next question. Which of the following compounds is in the decreasing order of reactivity of SN1 reaction? Decreasing order means the one which is tertiary will be more reactive, the one which is primary will be less reactive. So if you see, C will be more reactive, okay, and then if you see A will be there, okay. Now Cl, here carbocation will be less stable, but here carbocation will be more stable because it will have more plus I effect. So then it will be B and last will be D. So CABD, that is your option number C. Now let us see the next question. Vapor pressure. Our figure represents the vapor pressure versus time graph for 2 pure volatile liquids and a solution formed by 2 liquids. Which curve represents the solution? So if you see, A is there and C is there, right? So we have studied about azeotrope. When we mix 2 solutions, they boil at a common temperature, okay? So here the solution will be your B, okay? Now which curve represents the liquid with the strongest intermolecular forces? So if you want to calculate the liquid at a strongest intermolecular forces, means at a particular temperature, okay, the vapor pressure, or at a particular vapor pressure, the one which is having the highest boiling point will have the highest, strongest, or you can say the strongest intermolecular forces. Now let us consider a particular vapor pressure here. Okay, now if you see at this vapor pressure, this one C is boiling at the highest temperature, the boiling point of C is maximum. So that means the force of interaction, force of attraction or the intermolecular forces in C is strongest, right? So C will be your this two. This one answer will be C. This one answer will be B. So correct answer is option number A. Okay. Next question. Which one of the following statements is incorrect regarding the acetal and ketal formation when propanol and propanol are separately reacted with ethanol in presence of anhydrous HCl? So if we have the reaction of propanol, okay, one more carbon I have to add, with in presence of HCl, okay, and yeah, so what happens, this O takes this H plus, right? As a result of what happens, we get CH3, CH2, CO plus H, okay, and then we have this side. So now since oxygen is already, it was more electronegative, now it is oxygen plus, so it will pull more electrons and then the electrophilicity of this carbon will increase. The first statement is given decreases the electrophilicity of the carbonyl carbon. That is the wrong statement. Okay, we have to also find the incorrect statement. So the correct answer for this question will be option number A. Okay, so let us see the next question. Choose the incorrect statement from the following. Tetrahedral complex of Ma2B2 does not show geometrical isomerism. So you know, or any tetrahedral complex do not show geometrical isomerism. So this statement is correct. Now coordination entities of the type Ma3B3 do not exhibit geometrical isomerism. So here you know, in the type of Ma3B3 we have Fak and Mer type of geometrical isomerism. So this statement is incorrect because they show or they exhibit geometrical isomerism. So correct answer for this question will be option number B. Now next question. 0.1 solution of AgNO3 is taken in a conductivity cell and the potential difference of 40 volt is applied across the ends of a column of this solution whose diameter is 4 cm and length of the column is 12 cm. The current used is 0.4 ampere. The molar conductivity of the solution is. Okay. So first of all, you have to be calculating molar conductivity. So the formula for that is kappa into 1000 by C, right? So if you see here, concentration is given 0.1. If we can find the kappa value, we can get the lambda m value. Now what's the formula to calculate lambda kappa value? It is 1 by R into L by A, right? Now if you see 1 by R, L value is given, that is your 12 centimeter and area is pi R square. So you can use that formula. So I'll get 12 centimeter divided by pi R square, 3.14 into, this one is 2 centimeter, it's square, right? L by A, pi R square. Now here you see there is no value of resistance given. So how we can solve that? So you know V is equal to I into R. So 1 by R will be equal to I by V, right? So current given here is your 4.4 ampere and the voltage given is 40, right? So I can write it as 0.01. Okay, so the 1 by R value is 0.01 into 12 divided by 3.14 into 4. Okay, so this is the value of kappa. Now this we have to substitute in the value of molar conductivity, that is lambda m. Okay, so lambda m will be the same, so I can write it as 0.12, okay, divided by 3.14 into, we have 4 into 1000 by C is again 0.1. So now if you solve this, you'll be getting around 95.5. So correct answer for this question will be option number B. So let us see the next question. A statement of assertion and reason is given. Okay, energy of 2s orbital of hydrogen is less than the energy of 2s orbital of lithium. So if you see the formula for energy of orbital, that is minus 13.6 z square by n square, right? So if the n value, right, is here n value is same for both, that is second cell. Now it is proportional to z. Okay, so now what we can say is for hydrogen the z value is 1, right? And for lithium the z value is hydrogen, helium, lithium, that is 3, right? So now if you see, it will be minus 9 into this one, and for this one it is minus 1 into this one. So obviously the hydrogen energy will be more, right? So that is why this statement is incorrect. Now energies of the orbital in the same subshell decrease with the increase in atomic number. Yes, you can see as there is a negative here. So as we go far away from the nucleus and the z value is increasing, then the energy will keep on decreasing. So the first statement is assertion is incorrect, but reason is correct. So that is why the correct answer for this question will be option number C. So like for example, energy of hydrogen for in this case will be minus 13.6. Z square will be 1 square by 2 square is 4. Whereas for energy of lithium will be minus 13.6. Here it will be 9 divided by 4. Okay. Now if you see, this value will be negative value, right? So this one will be bigger, this one will be smaller. Okay, now let us see the next question. 300 ml of aqueous solution of NaOH with pH value of 10 is mixed with 200 ml of aqueous solution of HCl with a pH value of 4. Then what will be the pH value of the resultant solution at the room temperature? Okay, so this question is from ionic equilibrium, again an important question. So first of all, you see NaOH is there, okay, its pH value is 10. Then what is its pOH value? It is 4. Then what is the concentration of OH minus in this? 10 to the power of minus 4. Okay. Now, if we have this one and the volume given is 200 ml. Okay. Then what will be the number of moles of OH minus? We have 200 into 10 to the power of minus 4 millimoles. Okay. Now, if you see for H plus, we have this pH of 4, and then if I have for H plus, okay, then it will become 10 to the power of minus 4, and the volume here given is how much? 200 ml. Okay, so sorry, this was 300 ml. Okay, so we'll get 200 into 200 ml, and if I want to calculate number of moles of H plus, it will be 200 into 10 to the power of minus 4. Now these two are reacting, so if you see NOH and this one will react, so how much will be left behind? Number of OH minus left behind will be 100 into 10 to the power of minus 4. Okay. Now if I want to calculate the molarity of OH minus, so number of moles, okay, divided by the total volume, so that is 300 plus 200, that is 500, right? So 1 by 5 is 0.2 into 10 to the power of minus 4, right? So now we can calculate the pOH value from here. The question has asked you to calculate the pH value, right? So if I calculate here, I can write it as 2 into 10 to the power of minus 5, right? We can write it, this one as 2 into 10 to the power of minus 5. Now you just take log on both sides, so we'll get minus 0.2301 minus 5. So we will be getting around pOH will be somewhere around 4.7. Okay, if pH, then pH will be somewhere around 9.3. So correct answer for this question will be option number C. Next question, aniline undergoes the reaction with reagents given in the order shown. What is the product formed at the end of the reaction? So if you have first aniline, okay, and then if you treat it with aqueous Br2, so we know aniline is highly reactive, highly active group, so we will get 3 bromine groups added here. Okay. Next, if you treat it with NaNO2 HCl, so this one will be converted to the diazonium salt, and we will get here N2 plus and Cl minus. Okay, and here I'll get bromine and one more bromine and one more bromine. Next, it is telling you to add hypophosphorus acid. So once you add hypophosphorus acid, this one will be replaced with H. So we will get this compound Br, Br, Br and H. Okay. So this one is your what? 1,3,5 tribromobenzene. So correct answer for this question will be option number A. Next, which one of the following shows the correct increasing order of basic nature of the given compounds? Okay, increasing order of basic nature. So if I see first phenyl methanamine, so phenyl methanamine structure will be this one. Okay, phenyl methanamine. Then we have N-ethyl ethanamine. So if you have N-ethyl ethanamine, so we will have here, one second, sorry, let us draw the structure first correctly. First of all, it is ethanamine, right? So CH3, CH2, NH2. So out of that, one H is replaced with, okay, so N-ethyl ethanamine. Next you have NN-dimethyl aniline. So next structure will be your NN-dimethyl. So we have NN. So this one is not the NN-dimethyl aniline. and the next one is NN dimethyl methanamine. So that is your N with CCH3 groups. Okay, so now this is your A, sorry, this is your A, this is your B, this is C, and then this is D, right? I have written it correctly, I think. Yeah. Now if you see the order, okay, so if you see, first of all, in this the lone pair is in conjugation with the double bond, so it is less available for the donation, so C will be the least one. So you can eliminate all these options and first check on C. Now if you see the other groups, okay, here then A will be there, CH2 will be there. Why? Because you see this is a primary group, only one set donation is there, R group only one R group is there, so that is why next will come A. Now if you compare D and B, this is methyl group where it is a tertiary group, and these are two ethyl groups, right? So ethyl groups will have more electron donating nature, okay, because they have more plus I effect as compared to methyl group. So that dominates over this one, and then we get D and then we get B. Okay, so correct answer for this question is option number D. Okay, next one, delta GF of formation of C2H2. C2H2 is 2.09 into 10 to the power of 5, and for C6H6 it is 1.24 into 10 to the power of 5. And you have to calculate the equilibrium constant for the cyclic polymerization. So if you know this is the reaction, will give you C6H6, right? Now if I want to write the delta G of this reaction, this will be equal to delta G of product, that is 1.24 into 10 to the power of 5, and then minus 3 times of C2H2, that is 2.09 into 10 to the power of 5, right? So now if you solve this, we'll get the delta G of this reaction. Now what we have to do is we have to calculate delta G of the reaction is equal to minus 2.303 RT log of K, right? Now what is this value we will get? So if you just want to calculate here, 1.24 minus this will be 3 9s are 27, 2, 6, right? So we'll be getting 5.03, right? I'll just subtract here 1.24. So we'll get 5.03 into 10 to the power of 5 minus 5.03 minus 5.03 into 10 to the power of 5 is equal to minus 2.303 into R, okay, into T. T is your which value? Temperature is given 27, means 300 Kelvin to log of K. So now once you solve this, we can take antilog on both sides and we can get the value of K, which is your 1.4. So if you calculate this log, K value will be coming around 87 point something, or we can say 88. So K value will be something in the power of 10 to the power of 88. So you can see only one option in that way. So correct answer is option number C. Okay, next, a carbonyl compound X when reacted with methyl magnesium bromide. X reacted with methyl magnesium bromide followed by hydrolysis gave a product Y. Okay, now when Y is heated with copper and 573 Kelvin, it gave Z. Okay, and Z is 2-methyl but 2-ene, right? Then identify X. So if you see here, whenever you heat with copper and you are getting an alkaline, that means Y must be a tertiary alcohol, right? So if you see this structure, this is what? 2-methyl but 2-ene, right? So that means what? Here there will be one OH group, so this one must be this structure, right? Now if this one has come, so what should be this one here? This must be a propanol compound. Then when you add methyl magnesium bromide, we'll get tertiary alcohol, right? So this has to be a ketone. So what is your, okay, we had but 2-ene, right? So I have one more here, carbon. Okay. So the question, so here should be the compound given should be your butanol or butane 2-ene. That is correct answer is option number C. Okay. Now let us see the next question. 2-methyl but 2-ene. Sorry, one small. So let us see the next question. A carbonyl compound X, okay, when treated with methyl magnesium bromide, okay, followed by hydrolysis gave product Y. Okay, and then when Y is treated with copper at 573 Kelvin, it produced 2-methyl but 2-ene. So we have this one. Okay, 2-methyl but 2-ene. Now if you see here, this one must have come like when you're heating copper with something and you're getting an alkene, then that is a symbol that it might be, or it must be a what do you say, it must be a this one should be one tertiary alcohol, right? So for tertiary alcohol, what should be there? Then only we'll have a double bond here. So now we can expect that this one must be this structure. Okay, then for that reason, to get a more stable product, we have done this one. So now if this is the X, then this has to be the Y, right? Then only this one will attack and we'll get this one. So this is your butane 2-ene or butanol. So correct answer for this question is option number C. So let us see the next question. Identify the reagents 1 and 2 to be used in the course of the reaction. So first, copper 2+ is there. It will oxidize your aldehyde group, right? So we will get Cl and COOH group here, and we have C double bond oxygen here. Now if you see, this one is an alcohol, this is an acid, so ester formation will take place. So we'll get Cl and then we'll get C double bond O, then we'll have CH2 and then we'll get CH3. Okay, now what happens when you give it dival H, right? That can reduce your esters to aldehyde. So what we'll get here, we will get the compound Cl and COH. Okay, and then we have here C double bond O. Now if you see, this compound doesn't have any alpha hydrogen. When you treat with undergoes self oxidation and reduction, that is your Cannizzaro reaction, right? For that, what is the reagent? Concentrated NaOH or concentrated KOH. So first one will be your dival H, then this one will be this one, that is concentrated KOH. So correct answer will be option number A. Okay, next, given below are the 4 species with 1 odd electron of the carbon atom. You have to tell the most what we can say most stable one, right? So if you see here, we have 3 phenyl groups, so it will be stabilized by resonance. So B will be the most stable. Here we have 2, so after B, C will come. Now if you see here, there are 3 alkyl groups. Here there is only 2 alkyl groups, so after C, A, then D. So correct answer is option number B. Now let us see the next question. Which one of the following compounds when react with NaOH undergoes substitution nucleophilic bimolecular reaction with retention of configuration? So there will be retention of configuration when there is SN2 mechanism and the reactant is like not optically active, or it doesn't have any chiral carbon. Then there is retention of configuration. So if you see here, it will not undergo SN2. Here if you see, this one also difficult to undergo SN2 because it is a chiral carbon. If you see this one, right, this carbon is not a chiral carbon because it has 2 similar groups. So there will be retention of configuration. Correct answer will be option number C. Now if you see the next question, the eclipse and the staggered formation of ethane continuously flip from one form to another. The torsional barrier between the conformers of ethane has a high value of about 50 kJ per mole, and this restricts the free rotation around CC bond. So this is incorrect. So single bonds are always very flexible for rotation. So your assertion is correct, but reason is incorrect. So correct answer is option number D. Now if you see the next one, so here we have some matching here. So if you have adrenal cortex, it is for your Addison's disease. So you have A with S. Okay. Next B, if you see epinephrine, it is with your responses to external stimuli. So B is P. And then if you have estrogen, that is a steroid hormone. So C is Q. And then if you have thyroxine, you have iodinated derivative of tyrosine amino acid, that is your R. So this matches with your option number A. Correct answer is option A. Now if you see next question, you have to identify the following. Reactant A, molecular mass is 78 gram per mole, undergoes a series of reaction. So first of all, there is MECl and catalyst, we got C7H8. Then we have 3 moles of Cl2, we got C plus HCl, and then NaOH is treated, right? Okay. The question is to predict the D1. Okay. So now if you see, we have CH3Cl with the catalyst group and we have added. So this must be benzene because you can see in option the benzene is ranked. So we can tell that this was A was benzene and then B is your toluene, right? C7H8. Okay, B is toluene. Now when 3 moles of Cl2 is there, what will happen? This one will replace all the chlorines. So we will get CCl3. Now when you treat it with NaOH, all the chlorines will be replaced with OH group. So we'll get C, OH, OH and OH. Now you know 2 OH groups on the same carbon is not stable. So that will be dehydration and we will get benzoic acid. So correct answer for this question will be option number A. Now next question, the boiling point of a 4% aqueous solution of non-volatile solute P is equal to the boiling point of X% solution of another non-volatile solute Q. Okay, so boiling point is same, means I can write delta TB is same. Okay, that means this molality will be same for both, right? So we can say that M of molality of P will be equal to molality of Q. Now what is the molality formula? Given mass by molar mass. So what is this? 4%, right? Divided by the molar mass of P into 1000 by mass of the solvent. So 100 gram was there and 4 gram is your solution. So how much is this one? 96. That is equal to X% of Q and molar mass of Q into 1000 by 100 minus X, right? Because when you say 4%, that means in 100 gram, 4 gram is the solute. So in X%, in 100 gram, X gram is the solute. So what is the mass of the solvent? 100 minus X. Now we can cancel these two things, right? Now here you can see MQ is equal to 4 times of MP. So here I can write 4 times of MP. This MP will also get cancelled. So I'll get. So let us see the next question here. The boiling point of 4% aqueous solution of a non-volatile solute P is equal to the boiling point of X% solution of another non-volatile solute Q. The relation between the molar masses of MQ and MP is equal to 4 times of MP. What is X? Okay. Okay. So if the boiling point is equal, then we can say that the molality is equal, right? So I can write molality of P is equal to molality of Q, right? Now what's the formula for molality? Number of moles. So 4% means out of 100 gram, 4 gram is there. So 1 second. Okay. So we have here 4 gram divided by the molar mass of MP, I'll write like this, into 1000. Mass of solvent is 96 and in MQ we have X%, okay, divided by MQ into 1000 by 100 minus X. Like X gram is this one, so we have 100 minus X left. Now if you want to calculate this one, what we can do here, in place of MQ I can write 4 times of MP, then MP will get cancelled. So I can write 4 by 96 into 4 is equal to X by 100 minus X. Okay. Now you have to solve this X value, and once you solve it, we'll be getting around 14.29. So the correct answer for this question will be option number B. Okay. Now let us see the next question. Correct statements about insulin. Okay. So insulin is a globular protein, that is correct, with 51 amino acids. There are 3 polypeptide chains. This is incorrect. There are 2 polypeptide chains linked by disulfide bonds. Okay. So these 2 statements are correct, that is A and C. So option number B is your correct answer. Now let us see the next question. Given below are 4 subatomic particles traveling with the velocity of v. Which of them will have the shortest wavelength? So you know this de Broglie, we have de Broglie wavelength formula, lambda is equal to h by mv. So if mass is more, wavelength will be the shortest. So if you see out of all this, alpha particle mass is the highest, so its wavelength will be the lowest. So correct answer is option number C. Okay. Now let us see the next one. The mass number of an element is x, with element x is 175 with 104 number of neutrons in its nucleus. Into which one of the following orbitals will the last electron enter? So if you see, the mass number is 175 and the number of neutrons is 104. So from that we can calculate the atomic number. So Z is equal to 175 minus 104. So that is 71. So 71 is your lutetium element and the last electron enters to the 5d orbital, right? So the correct answer for this question will be option number C. Okay, next one. What is the number of monochloro derivatives of ethyl cyclohexane possible? So we have ethyl cyclohexane. So we have to see how many different products we can get. Okay. So one is, so we can see here. Okay. So one is, if you replace any of this hydrogen, we'll get one product. If you replace any of these hydrogen, we'll get another product. Here we have one hydrogen, so that will be third one. Here this is fourth, this is fifth, and then this is sixth. These three are same as this one, right? This is same as this is same as this. So we have 6 different types of hydrogen. So we will get 6 products. So correct answer for this question will be option number C. Okay, now let us see the next question. Which one of the following is the correct IUPAC name of the given compound? So if you see, we can name 1, 2, 3, 4, 5, 6 and then 7, right? So we have 2,3 dimethyl and then we have 5th bromo, right? So alphabetical order. 5-bromo-2,3-dimethyl heptanoyl chloride. So correct answer is option number A. Okay, easy question. Next one, an aromatic hydrocarbon A. Okay, so there is an aromatic hydrocarbon A with molecular formula C9H12. Okay, undergoes air oxidation followed by reaction with dilute HCl to give B as one of the product. So we have oxidation, then we get B. Compound B forms a white precipitate on treatment with Br2. Okay, next is the sodium salt of B reacts with CO2 at 400 Kelvin under high pressure followed by acid hydrolysis to C. So we have here C. Compound C reacts with acetic anhydride and concentrated H2O4 to form D. Identify the compound D. Okay, so if you see this one C9H12 then undergoing air oxidation followed by reaction with dilute HCl to give B as one of the product. So this one is your phenol and this one must be quinol, this cumene, right? We have this method of preparation. Okay, so A is your cumene and then when you do hydrolysis B is your phenol. Right, now next part, if you see sodium salt of B reacts with CO2 at 400 Kelvin under pressure to give you C. So if it reacts with CO2, here we will get OH and COOH. Right, now this one is your C. Now this one reacts with your acetic anhydride. So if it reacts with acetic anhydride, that is CH3CO whole 2O, then we'll have a addition reaction here, nucleophilic addition reaction, and we will get here one is OCOCH3 and the next one is COOH, right? So OCOCH3 and COH, correct answer is option number C. Okay, now let us see the next question. So chemical kinetics, you have been given with this reaction and you have to write the differential rate equation. So for this one I can write minus 1/3 dx by dt is equal to minus 1/2 dy by dt, okay, is equal to minus 2/5 dz by dt. Okay, so now if you see, we can multiply these two to this side. If I take these two equation, only considering these two equation, I can write minus 2/3 dx by dt, okay, is equal to dy by dt. Okay, another equation, if I multiply 2 to this side, then I can write minus 4/5 dz by dt is equal to dy by dt. Right, now you can see RHS is equal, that means this one will also be equal. So I can write minus 2/3 dx by dt is equal to dy by dt is equal to minus 4/5 dz by dt. Then we can cancel all the negative sign. So this will be the answer. Correct answer is option number A. Now let us see the next question. So this is very easy question from electrochemistry commercial cells. You can see this one. Zinc is used as a zinc and mercury is there, so that will be a mercury cell. So we have A with S, so we can eliminate first option. Then you have H2 and OH minus, so this is your fuel cell, so B is P, so that is there in this option, ASBP, and this option we can eliminate. Now if you see Zn and Zn2 plus, that is your Leclanche cell. So we are having C with Q, so C is with Q, this one also eliminate, so correct answer will be option number D. Okay, and the last one D and R is your nickel cadmium cell. Okay, next question. If the enthalpy of formation of diatomic molecule AB is minus 400 kilojoule per mole and the bond dissociation energies A2, B2 and AB are 2:1:2 ratio, what is the bond dissociation enthalpy of B2? So another question from your thermodynamics chapter. So we have been given with A2, B2 and AB. So ratio is 2x, x and 2x. Okay. Now let us write the formation enthalpy of this one. A2, B2 gives 2AB. Okay. So if this is the reaction, okay. Now for forming 1 mole of AB, we require 400 kilojoules. So if we want to form 2 moles, we will get 800 joules. Okay. So now I can write the delta H of this reaction is equal to bond enthalpy of A2 plus bond enthalpy of B2, okay, minus 2 times of bond enthalpy of AB. Okay. Now if you see, delta H of the reaction will be 800 because I am considering 2 moles of AB has formed, right? So that's why it will be 800. that is minus 800 we have. Then bond enthalpy of A2 is 2x and this is x, okay. Then minus, this is again 4x, right. So now if you solve this, we will get minus x is equal to minus 800. So x is equal to 800. So x is nothing but the bond enthalpy of B2, that is 800. So correct answer is option number A. Okay. Now let us see the next question. Choose the incorrect statements from the following. The ability of fluorine to stabilize the higher oxidation state of transition metals exceeds than that of oxygen. So this is incorrect statement. You know, oxygen has more tendency to stabilize the higher oxidation state because oxygen can form double bond, right? So that is why this is the incorrect statement. So correct answer is option number A. Okay, now next see this one. Given below are 4 equations using the molar conductivities at infinite dilution of various electrolytes. Which one of the following represents the correct equation? So if you see here, NaBr and NaCl cannot be equal to KCl and KBr because this side there is no K and that side there is no Na, right? Next one, if you see HCl plus KOH, okay, HCl plus KOH will give you KCl, right? Now if you subtract KCl from this one, what will be left? Water. So that is what is given here. So equation 2 is correct. So correct answer for this question will be option number B. Okay. Let us see the next question. So this is very easy question from your chemical bonding geometry and shape. So for A, ClF3 is your T shape. So A has to be S. So there is only one option with this one. We can eliminate all this, but we will check others also. BrF5, right? BrF5 will be your BrF5, right? So that is your pentagonal bipyramidal, square pyramidal because it has 5 bond pairs and 1 lone pair. So that is your B will be your R, right? And then if you have SF4 is your seesaw structure, so that is P, and IF7 is your IF7 will be your pentagonal bipyramidal, right? So correct answer for this question will be option number C. Okay, next if we see, next we have to match the carbocation with the names given. So first if you see 2-methyl butane 1-OL, we have this one 2-methyl butane 1-OL. So here what will happen? This one will leave first of all and we'll get a primary carbocation here. Okay. Now if you see, what we can do is we can have a hydride transfer to get it a stable carbocation because this is primary, and once you do a hydride shift we can get a tertiary carbocation. So what I can get here is plus, right? So if you see which one is given, that one CH2 CH3 and we have this one, right? So I can say this A has to be R. So there is only one option with that, so we can mark option C as the correct, but we can check for others also. Now butane 2-OL. So this one will form this carbon. So butane 2-OL will be, B will be S, right? B will be S here. Now if you see 3,3-dimethyl butane 2-OL. 3,3-dimethyl butane 2-OL. So if here it goes, we'll get a carbocation here, which is a secondary. Then what we can get is a methyl shift. So I'll get like this. We'll have a carbocation here, this one, and then this one is a shift here, and then this one, right? So this one what we will get, I think this one, right? CH3 whole 2 and then C, this one. So C will be your P and D will be your Q, the primary one. So correct answer for this question will be option number C. Okay. Next one, identify the pair of molecules both which have the positive values of dipole moment. Okay. So NF3 and CHCl3 both have positive dipole moment. CHCl3 because there is 1 hydrogen and 3 chlorine, the net dipole moment will not get cancelled. And NF3 has a lone pair, so that is why also it is a pyramidal shape. In this one, this is having 0 dipole moment, this is 0 dipole moment, this is also 0 dipole moment. So correct answer will be option number A. Okay, now let us see the next question. Given below are 4 molecular species, identify the species which exhibit diamagnetic nature. So diamagnetic nature, you know, all positive electrons like odd, if we have even number, then it will be diamagnetic except for 10 and 16, right? And odd number electrons will be paramagnetic, right? This one we know. So if you say N2 plus is 7 plus 1, 14, and then 1 electron is less, so that is 13 electrons. That is 13 electrons, so it will be paramagnetic. Now if you see O2 minus 8 plus 8, 16 plus 1, 17, this is also odd, so it will also be your paramagnetic. Now B2 is 5 plus 5, 10, but we know for 10 and 16 that is exceptional. So we will have B2 is also paramagnetic. Now if you see carbon 6 plus 6, that is 12, and it is an even number, so it will be diamagnetic. So the correct answer will be D, that is option number C. Okay. So if you have found this video helpful, please like, share and subscribe our channel. Thank you.